Hi guys, welcome to Learning Electronics Repair. This is the RTX 3060, which I picked up from the car boot sale. This is the one the guy wanted €20 for, said it was working, and said, oh, actually no, it isn't working. So I had a good look at this. I actually made a couple of videos about it. I will link them to this one if you want to see the history, or maybe you remember what I did to this. So the first time around, I couldn't really find any problem with it to explain why it didn't work. I did all the basic checks. And then in the second video, I went more in depth with it to the other reasons it might not be working. So it's not detected at all by the PC. It powers up, okay, all the voltage rails come up, but it's just not detected. Initially, it wouldn't come on at all. You can watch the first video about that. And on the second video, once I had the thing powered up, I eventually figured out why it's not being detected. I'm just going to explain a few basic things on paper with this, because some of you feel that these graphics cards are very complicated, and you could argue that case, but you could also argue the case that actually they're fairly simple, really. So let's have a quick look at what could go wrong with this. We'll talk about what I found wrong with this, and then let's see if we can fix it. So let's just consider a block diagram of a GPU, and this applies to any GPU basically. So we have the GPU itself. This is the processor. Okay, this is what's doing the work. This is the expensive bit. And the processor requires power, and it doesn't only require one power rail, it actually requires a number of different ones. Let's have a look to see what the GPU is doing, and then discuss why it might need more than one power rail. In fact, it does need. So basically, the GPU talks to the computer. Your computer sends information to the GPU, and the GPU processes that information and sends it to your screen. That's basically what this is doing, okay? So we have communication, GPU to the PC. This is your PC, interestingly shaped, yeah. And of course the graphics card fits into the PCIe slot, okay. And this is how it communicates with the PC. It then has communication to the monitor. This is your screen, we'll call it. And that's done often by HDMI, but it could be done by some other method, and it may actually support more than one monitor, one output, but for the point of this discussion, it has a screen, okay? For the GPU to process the data that the computer is sending to it, it needs to store information. So it has, which you can write to and read from. Video RAM, VRAM, okay? Video RAM. The GPU actually needs another form of memory as well, because the VRAM is volatile RAM. So once you power the card off, everything is gone. And the GPU itself has no internal storage. Yes, it has registers and such like, you can talk to semantics, but it doesn't have internal memory, and certainly it doesn't have non-volatile memory. But when you first power up, the GPU has to run some software or do something to be able to talk to the computer, to talk to the RAM. It needs to know how much RAM have I got, etc. Yeah, and that information is stored in the BIOS. Okay, BIOS. Just like your computer has a BIOS so it can boot up, the GPU has a BIOS so it can boot up. And this, as I say, contains timing information for the RAM, information about what it is, so we can tell the computer, I am this, etc. Okay, so that's basically what there is on your graphics card. Now it should make sense, perfect sense, that if the GPU is talking to the BIOS, the RAM, sending the information to the screen and talking to the PC, it needs to be able to talk to those things using the same voltage supply as the thing it is talking to. Okay, so the GPU doesn't have one power supply. Inside the GPU, you've got the GPU core. That is the video processor, if you like. And sometimes as well, you will have the memory controller. You may have a separate memory controller here rather than talking directly to the RAM. Okay. And it will also have the interface which talks to the PCIe. PCIe Express or PCI Express. Yeah. This is shortened generally to PEX. Okay, and it has a PEX interface which allows it to talk to here. Okay, and it needs to talk to the screen and the BIOS. And these systems run on different voltages. So, as an example, this is just an example. The VRAM may run on, say, 1.35 volts. Okay. The BIOS could be a 1.8 volt BIOS. It could be a 3.3 volt BIOS. Let's put a 1.8 volt. So the BIOS is 1.8 volts, say, for example. The PCIe slot, the communication here, PEX, runs on 0.9 volts. Okay. HDMI often a similar voltage, could be something different. Could be 0.75. Again, it just depends on the graphics card and the type of GPU. Okay. So this chip also needs supply for the GPU core as well. Okay. Now the GPU core may be 0.8 volts, something like that. The voltage for the memory controller, if it has one built into the GPU, would be very similar to the RAM voltage, but maybe different. So this chip and these all need power supplies, and we need a number of them. So we certainly need to have the GPU core voltage, V core. Okay. We need to have the VRAM. We may also have V memory control, V mem control. Okay. We'll certainly need a voltage supply for the BIOS, so we'll need voltage for the BIOS. Okay. And we'll need voltage for the PEX as well. Okay. And we will need some more voltages, because when you power up your computer, it's not a case that you press the power button, all of these voltages just appear. They have to appear in the correct order. Okay, the GPU expects different parts of itself to be powered up in a sequence, and this is called power on sequence. See, nice and easy. Yeah, power on sequence. And the power on sequence is controlled by transistors and logic gates to make sure that all the voltages come on in order. And it also makes sure that after, for example, VRAM comes on, if it then wants to put V memory control on, it says, okay, are you good? I'll have this one, and then say you wanted PEX. Okay, this is good. Now I want that one. It enables each one and waits till they're okay. And it does them in sequence, so they all have to receive a signal, an enable, to say switch on, and they all reply with a power good to say, yep, I'm up, and the voltage is stable and correct. Okay, and the power on sequence logic is what handles all this. The logic may run on 3.3 volts, may run on 5 volts, it may be a mixture of those. So these are more voltages which we now have. 5 volts, 3.3 volts, 1.8 volts. This is the order they normally come on in. PEX. And then RAM. And then memory controller, or they both come on together at the same time. And then lastly, core. Okay, that's the order they come on. Now, coming into the graphics card from your RTX power supply, the two voltages, 3.3 volts and 12 volts. Okay, either on the PCIe connector or 12 volts here. Yeah. And all the other voltages on the graphics card are generated from those two. You do have 5 volts in your PC, but it doesn't pick that up from the PCIe slot. Actually, the graphics card generates its own 5 volts from the 12. Okay, and the 12 comes in here, and it also comes in here as well. So if the graphics card is low powered, it only needs this connection. If it draws more than about 75 watts, it has to have that one as well. Okay, so for your graphics card to power up, it has to have the 12 volts coming in, the 3.3 coming in, yeah, in, and then it generates the 5 from the 12, and now it's got the 5 and the 3.3 is already here. It can then power up all this sequence logic that can go through its business and switch on each voltage in turn. Okay, enable, are you running? Yes, power good. Next one, enable, running, are you okay? Yes, power good. You see, it's like a daisy chain. Okay, and after all that's happened, all the graphics card is powered up. Will it run? Well, it should run, but some things have to happen first. First of all, before the processor can run like a CPU, it needs a clock. A clock signal. That comes from a crystal on the graphics card, usually 25 megahertz, which generates other frequencies as well, and that gives the clock to the GPU. Okay, can the GPU now run? Well, no, because it's got all the power rails are up, it's got the clock is running, it's now executing code, but it's got nothing to execute. It's not talking to the computer yet. Yeah, and the reason it's not talking to the computer yet is because it's reset. So by default, the GPU is reset until two things happen. One is that all the power rails are up and we get a final power good signal, okay, coming from all this sequence logic. Yeah, so we have a power good, and the second thing that it needs is PCIe reset. So the computer has to send a reset signal, and it does this by putting the voltage here from low to high. Okay, the power good does the same, goes from low to high. Okay, high being, well, whatever voltage depending on this logic, 1.8, 3.3, whatever. Okay, so it has power good and reset, and that comes into an AND gate. So what an AND gate does, it says if this is high and this is high, then the output reset goes high. Okay, technically we should put a slash on there, which means reset is low. Yeah, reset is active low, and then when these go high, this goes high, the reset comes off, and the processor can now run. It can start running, but it won't do anything now until the computer first says, is anybody there? Yeah, it sends some commands to it to say, hello, is anybody there? Yeah, and the GPU responds to say, yes, I'm here, I'm an RTX 3060, blah, blah, blah. Okay, and the computer now knows it's there, it can start talking to it. And for that to happen, this interface needs to work. So all the PCIe lanes here need to be working. Yes, you can put a mining adapter on it or work with just the one lane, but at least that one lane needs to be working. And there's also a clock signal coming from the computer as well, 200 megahertz clock coming from the PCI. Okay, this clock is not for the GPU. This clock is for the data transfer between the two. Think of it as a PEX clock. Okay, that's the best way we can call that. So that clock has to be running, all this interface has to be good, you see, all this has to be good, goes through some little capacitors here, they have to be good. It needs to be able to communicate from here to the GPU, otherwise the PC will never even see it's there if it can't receive the hello and reply, yes, I'm here. Okay, so those are all the things that need to happen before your graphics card can put a picture on the screen. Of course, once the GPU receives the request, what are you, is anybody home? It doesn't know. It has to read that out of the BIOS. So this has to be working as well. The BIOS has to be working and has to contain valid data for the GPU to be able to reply back to the computer with something sensible, okay? To make that into a resume, and these are things you need to check. You need to check, do we have 12 volts and 3.3 volts coming in, both on the PCIe connector and on, if there's an extra 12 volt connector, okay? Do we have power coming in? If we do, are all the other power rails there? Yeah, all these ones here, are the power rails up and running? Okay, if they are, then we have power good. Is the GPU clock running? We can do this with an oscilloscope. We can see the clock crystal. We can measure it, 25 megahertz. We can say, yes, we have a clock to the GPU. Okay. Has the reset come off? Is the GPU no longer held in reset? Well, we can measure that around this AND gate. We can look for the power good. We can look for the PCI reset and say, yep, that's high, the output is high. The reset's gone, yeah. The PCI lanes and PCIe clock. Yeah, that's this one. Not to be confused with the GPU clock. Well, we can see the PCIe clock if we have a fast enough oscilloscope. But anyway, we can measure in diode mode from all the PCIe lanes and the clock lanes to ground, and we can see if there's any obvious damage there. We can check the little capacitors on the other side. So we can test with a multimeter if almost certainly that is okay or not. Yeah. BIOS, well, we can check with an oscilloscope to see if the BIOS is being accessed. Yeah, there's a chip select or chip enable pin. Is it being accessed? If we know it's being accessed and the thing is still not working, we can take the BIOS chip off. We can unsolder it, put it into a programmer. We can program it. Yeah. So we can do things about that. If all that is okay and it still isn't working, then it's highly likely we have a problem with the GPU itself. It's not short, all the power rails are up, it's just not doing anything, brain dead. Yeah, so that we can usually check, although normally if that's the case, one or more of these supply rails will be short circuit or the resistances will be wrong. And then the last one is the VRAM. If it's got faulty RAM, it can run but may not be able to generate an image. It may not be able to even reply properly to the computer. Okay, so if everything else is okay, then we could have a problem here. This is something we can't repair, really, not realistically. This one, yeah, if you've got some RAM chips and some time and the necessary equipment and the necessary experience and skills, you can change them. We have software which will help us determine which one is faulty. But that's basically how you should go around fault finding on a GPU. Yeah. So after all these things are all okay, yeah, as you can say, that's okay. Go to the next one. When you get down to here, it's VRAM, and this is where you would use diagnostic software, kind of talk to the thing, and GPU. You need to try and figure out if one's faulty. Yes, it could be bad soldered joints under the BGA, etc., etc., but that is more specialised, I think. You will agree with me. But that's how you would diagnose this thing. Now then, with the one I had, first video I didn't have any power rails, and then I did. Okay, watch the video. And then it still didn't work. And then in the second one, I was basically as far as this. So I'd already tested that anyway. Tested the BIOS. So is the BIOS being accessed? Chip select. No, it never tries to read the BIOS. It doesn't get that far. So I knew the problem was somewhere above that. Okay, power good was okay. All the PCI lanes look okay. I tried this on a mining adapter with one lane. It still wouldn't detect it. I measured this with an oscilloscope. Yes, the clock was running, and that brings me to reset. And when I came to reset, I found that this here is high. Okay, and this here is high. Oh, low high, yeah. This is high. I think it was 3.3 volts on mine. I'd have to go back to look at the video. But I had voltage there, and I had the same on here. This is high, 3.3 volts. And this was low, 0 volts. Now, for this circuit to work, there's probably but only probably maybe a pull-up resistor here to 3.3 volts. I checked, I could see some resistance. A possibility is that this is shorted to ground. It wasn't. If it was shorted to ground, it's probably going to be shorted in this chip or inside this, okay? But I didn't have any low resistance to ground, so there's nothing holding this down. I've got 3.3 and 3.3 coming in. It must go high, and it doesn't go high. So on my card, that's the stage at which it's failing. And because it's failing at that stage, it actually never gets to read the PCIe lanes, and it never gets to read the BIOS. It never gets that far. Another good indicator of this is that the GPU is getting a bit warm but not hot. So if you get a GPU that's getting a bit warm but not hot, it usually means it's powered up. It just isn't doing anything, and being reset is a good reason. Okay, what's the theory? But that is a very good way to go about repairing any graphics card, and you'll probably find the fault somewhere down that. Just to mention these power good rails, if the power rails don't all come up, the first thing you should check is, are any of those power rails shorted to ground? Is there a short? If you find a short on one or more of core, PEX and BIOS, you can pretty certainly say, if it's on more than one of them, the short is the GPU, because all those go to the GPU. Yeah. If it's just on one of them, it may be a problem with the buck converter, the DC to DC converter that's generating that voltage rail. Yeah. If there's no shorts on them, it could be a problem in the logic, so it's not reading the power good from one of the stages, and therefore it doesn't send the enable to the next. But again, that's something you can do pretty well with a multimeter. So in our case, we have a GPU which is permanently stuck in reset. At least this gives you a starting point, because often when you pick something up, it's like, where do I start? And this gives you a step-by-step way to go about it. If you're not sure how to check any of these various things, I've made plenty of videos in detail about all of these things, and no doubt others have as well. So look around on YouTube. How do I test a GPU BIOS? How do I check the GPU PCIe lanes? How do I check the GPU clock or whatever? And you will find information there. And here is our graphics card. Okay. Quick look around. These are all the PCIe lanes. You can see like pairs of tracks all going that way around into the GPU loop. Okay. Same on the other side. We can see them again. PCIe lanes heading up towards the GPU. This is your GPU. This is the RAM. No, it doesn't have two RAM chips removed. You'll often find this. There's different versions of a card, a 6 gig and 8 gig version. There may be like a TI version which has a different chip, although it fits in the same place with more RAM, that sort of thing. Okay, so that's quite common. These coils are all your various buck regulators. These are generating all those voltage rails I told you about. Okay, this is where you would check for voltages, where you would check for shorts. We have controller chips. That one's controlling some of the voltage rails. We have some more here, Luke. We have a lot of transistors here on this one. These will be part of the power on logic. This is what is effectively switching the things on at the right time or in the right sequence. Yeah. The BIOS on this one is there. Okay. So that's basically where we would find most of those things we were talking about. On my card, the AND gate is here, this one. So this takes the final power good signal from the power on sequence logic and the reset signal from the PCIe slot, and when power is good and the reset is off, the output from here on pin 4 goes to the GPU, takes the reset off, and the GPU can now start running. Okay, so I have a replacement for this. As I mentioned before, I will link the previous 2 videos on this card. If you watch through them, you'll learn a lot more about diagnosing graphics cards. Basically what I just showed you on paper, but in practice. Okay. But what we're going to do on this video, we're going to change this and let's see if it works. There are a variety of ways of doing this, and previously I would have used hot air. Actually, I would use hot air to do this. So I'm going to add some leaded solder, and I said previously because I'm now doing these a different way, and that way is to add some leaded solder. Okay, to the chip here, 3 pins on this side. Okay, yeah, I know I've bridged them together, that'll just help to desolder it. And to do the desoldering, I'm using the secure hot tweezers. Just the simplest way to do these things, guys, I would say. Okay, go up on temperature a bit. I'll set it to 300. In fact, no, I'll go a bit more than that. 350. Okay. Here is our chip. And literally, I'm just going to pick this up. Almost had it. Okay. Nice flat tip on this. I'm using the big flat BC3. Does this better than anything else. Okay. Here are my replacement chips from AliExpress. Do I find fakes of these sort of things? No. Not worth faking, I think. They're easily available and cheap anyway. Why would anybody even fake these things? Not quite level, but good enough. Yeah, I know this thing's bent like Aladdin's slipper. There's done quite a bit of work, but it's fine. Actually, it works quite well for drag soldering. It's supposed to be a bent conical. It's more like a bent comical now, but it does the job, and it's looking good. Not perfect, but good enough for Gran Canaria, yeah. Good enough for Gran Canaria. And possibly Australia too. Okay guys, so, and gate replaced. It's time to test this, let's see if it works now. So quickly then, if we measure V-core, if V-core is there, we can pretty much say all the others are, because that's the way the power on sequence works. Let's have a quick look. Yeah, we got V-core. I won't let it get hot. If that's there, I think we'd have to say all the others are there as well. Yeah, that's VRAM, probably 1.35. This one. Yeah, same sort of thing, 1.35. This one. 1.8. Another one here, very close to it. 12 coming in. There's one here. 5. And there's another one up here. Probably PEX. We haven't found PEX yet, about 0.9. Yeah, 0.98, that'll do. So all the voltages are coming up. Let's have a look again to see whether we actually have the reset coming off the GPU. And on our graphics card, that is here. So you can see this is the PEX reset signal, and some here 3.3 volt sequence. This is the power good basically coming to this one. They get handed together as I described. Goes to this output here, okay. And this one is actually a level shifter. So it's used as an AND gate, but both inputs are connected together. And this takes 3.3 volt logic in. I think it must be 1.8 coming out. Okay, so pins 1 and 2 must be high, and they're both connected together, so they're either both are or both aren't. And 4 is the output, which should go high. Okay, and you can see this has a 1.8 volt supply, so that's a 1.8 volt output there on pin 3. So 1 and 3 should be 3.3 volt, 4 should be 1.8, and 5, the power should be 1.8. So let's see. So we start with pin 1. Okay, switch on. 3.2. Pin 2 should be the same because these should be connected to each other. 3.2. Pin 4. 1.8. And power must be 1.8. 1.8. So that is working now. So we know the reset's coming off. Let's see if we actually get an image out of this. Now, it might take a few seconds just to power up. Let's see. So I'll just see how hot it's getting. It's getting warm. Not really hot. And we have a picture. Gigabyte. Okay. So this appears to be working now. Let's put the heatsink back on and let's try it. Right, guys. I've just booted from my test rig. You can see it there with the graphics card in. We have the capture card on. We are in Windows. NVIDIA control panel. Yeah, so we have RTX 3060. I'm not sure which version of the drivers this is, by the way. It's what's on my little SSD, but it's almost full. In fact, I need to just set a bit bigger one. This thing's only a 64 gig. And I have like about 7 gig free. But anyway, it has drivers loaded. So let's just go to a little benchmark or something. Try this. Okay, loading. And it's running. I've just noticed the fans have just come on the graphics card. I'll show you that because I'll just get rid of the camera. One moment, you'll see it. Yeah, there, so the fans have kicked in as you'd expect. And that's running. So obviously it needs a soak test, but we have to say that this graphics card is repaired. We had no video at all. And I'm now running the benchmark test, as you can see. Just move myself out of the way there. So yeah, running 240 frames a second, roughly speaking, at 60, 61, 65 degrees centigrade, something like that, 64. So that's running really happily. Okay, and that worked nice. I mean, this machine's only an i3 4150, so probably wasn't pushing that to its limits, but yeah. Okay, it all came down to that little SMD AND gate at the end. Hope you enjoyed that, by the way. Hope it gave you some idea of how to go about graphics card repair. No matter what the GPU is, if you follow through that sort of sequence I gave you, step by step, if you're stuck at any step, well, ask down here, or I'll just try and link some videos for you. I think I've documented all of these in the past before. And yeah, that's a bonus. So that was the €20 GPU from the car boot sale, and it's working nicely. This will go into one of my PCs. It's just too nice, really, for that price to let it go anywhere. I'm sure I can make a decent profit if I sold it, but I think I'll find a use for it. Okay, guys, hope you enjoyed that, and I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now.